So number 14, chapter 1 was all lines. So we talked about like mid segments and distance and like lines and some more lines. Okay. Now we are going into chapter 2, which is angles. There's gonna be lots of angles all year. So this is probably the most important stuff that we've done so far is like just learning how to name them and learning how to read them. So for an angle, it says an angle is formed by two rays, which we have not talked about what a ray is. A ray has a stop point and a line continuing in one direction. Take off your headphones. Take off your headphones. Take them off. Take them off. All the way. Take them off. Thank you. Okay, a ray has a stop point and it continues forever in one direction. Somebody last class was saying that an angle is created by two lines. Two lines would continue into mathematical distance for literally forever. So it stops and then it goes, okay? So with a common endpoint, the common endpoint is called the vertex. The vertex right here is point B. So that's my vertex. So put that in your picture. The rays are called the sides of the angle, which I think is a little weird, but it's okay. So they're the sides. For your rays, your sides are technically, the way we're going to write this is from the vertex out. So you have two sides to your angle. You have BA, which is a ray. And then you also have BC, which is a ray. Both of these are sides to your angle. Then we're going to name an angle using 3 letters, because if you look at your picture, you have 3 letters on your picture. The middle letter must always be the vertex no matter what. So you have 2 options to write this. You could say angle, which kind of looks like an inequality symbol. So it's like a little sideways peace sign. Okay, so angle. We could say ABC. Or we can write it the opposite way. We could say angle CBA. So math people are lazy. We don't like words because we suck at spelling. If somebody writes angle and they're a math person, sometimes they'll write angel because it's like the same thing. So we say angle, okay? Sometimes if your picture is a single angle just floating out in the abyss, you can use a single letter, which is just the vertex. You're never going to do this because when we start getting into math problems, you're never just going to have one angle like this, because like this is easy peasy and that's like so cute and that's like not geometry. So you'll have like this. So you can't use a single letter because your angles, there's multiple angles in your picture. So this is like the least used. And then also math people are super lazy and we don't like to write things. So it says when referring to the measure of an angle, we use a lowercase m for measure. So looking at this picture, it says the measure of angle ABC is equal to 60 degrees. So you'll start, the higher math you go, the more words we come up with, like random things that we don't have to like actually write out words. Like when you get to calculus, eventually at some point in your lives, like you'll be writing whole sentences without any words like this. 3 little dots. Don't write this. This is like a side note. You have 3 little dots. That means therefore. Like what? Yeah. So it's like its own little language. So you'll literally be writing sentences with just symbols. Yeah, which is crazy. Okay. So for the types of angles, this is if they ask you to classify something. So if they want you to classify the angle, it's basically the type. So in middle school, we learned about this. What kind of angle is this? It's acute. An acute angle is less than how much?
90 degrees.
Good. It's less than 90. So we're going to say between 0 degrees and 90 degrees. It's not 0 because then it would be nothing. It's not 90 because then it would be a right angle. Okay. What about this one? Obtuse. And what angles would this be between? Good. 90 and 180. It's not 90 because then it would be a right angle. It's not 180 because then it would not be obtuse. It would just be like a straight line. Okay, so what is this one? This one's a right angle. And what's that square mean? 90 degrees. So when you see this square, automatically it's 90 degrees every single time. And then this is the weird one. How much is this going to be total? 180. So this is called a straight line. So we'll just call it straight. And it's 180 degrees. And like, if you think about it, like people are like, it's a line. Yeah. But if you think about an angle, you have like an acute angle and then it opens to a right angle and then an obtuse angle. And if it keeps going, then it's a straight line. So it's actually opening up to 180 degrees. So it's kind of like the total of it is 180 when it opens. Think about it like a mouth. Bloop, bloop. Okay. Then it would go into literally like all the way around into a full circle because it's going to eventually wrap around when we get into circles. Okay, so example 1, can anybody tell me what the vertex of this angle is? K, so we're gonna write K. Boop. Now we need to write the sides of the angle, which are the rays. Okay, so J and L, yeah, those are the rays, but we need to name them using 2 letters. So let's talk about this one. So KJ, because it goes from the vertex out. So KJ. And then I'm going to put a little ray on top because so that way I know it's a ray. What is the other one from the vertex out? K to L. So you're always technically working from the vertex out when it wants the sides. There's 3 ways we can name an angle. The first one is the easiest. What is the vertex? Okay, so we could say angle K. That's the one that's least used, least common. And then we can use 3 letters where the vertex has to be in the middle. So what would be one? J, K, L. K is still in the middle. And then if I reverse it, oh crap. If I reverse it, what is it? L, K, J. So any of these are acceptable, okay? K has to be in the middle. And then we have to classify the angles. What type of angle is it? Obtuse, because it's big. Okay, so try the second one. Take a minute. These ones are not terrible. Today's not terrible. What's up? Is that your review? Do you have a question on it? No. Yeah, after we do the notes. With the Excel. Yeah. Turn hands in. Oh, right. Oh. You can do it later. Do it. Okay, so what's the vertex of this angle? S, good. What is one of my sides? I should not say R to S. I should say S to R. If you write it backwards, honestly, I'm not going to mark it wrong, okay? But you're going from the vertex out, SR, and then what's the other one? ST, from the vertex out. Okay, what's one way you can name it? Good. Angle S. What's the next one? Good. Nice. What kind of angle is it? Right. Okay, good. See, I told you this was going to be easy. The next thing is congruent angles. So we talked about this word, congruent. What's it mean? It's not on the same line, but they're the same. Whatever you're talking about, it's the same. So whether it's on a line, they're 2 equal pieces, they're the same, they're equal to each other. So if you look at your little picture, congruent angles means that they're the same angle. This one says it's 75, that one says it's 75. So they're both 75, so they're congruent, okay? So if, this is kind of long, so I'm going to kind of like bring it up top. If I say the measure of angle A is equal to 75 degrees, so that's like a whole sentence that we just use like 3 letters for. The measure of angle A is equal to 75 degrees. And I say that the measure of angle B equals 75 degrees. If I know both of them are 75, then the angles are congruent to each other. So you can write a congruency statement, which we'll get to pretty often. We'll like go back to that. We could say the measure of angle A is congruent to the measure of angle B. So remember, congruent has that equal sign with that squiggle on the top, because we like to keep it spicy in geometry. So it's an equal sign because it means the same thing. There. Oh no. Okay, what's happening? My thing restarted. Hold on. Pause momentarily. Yeah, we're back. Okay. Are we good with this side? Let's go to the back. Okay. We are going to, do you need to see that? We're going to do the last 3 things on the top back, and then the bottom 2 you'll have to like practice. So that way, if you're not taking your test, you have something to do. So on the back, it says angle bisector for the first thing. Okay. So when you're talking about an angle bisector, so an angle is obviously an angle. A bisector, does anybody remember what a bisector does? Or if I bisect something? It splits in half. So it splits in half. Right down the middle, technically. So if it ever says bisector, you know it's splitting in half. It's 2 equal parts. So if you look at your picture, this part, if you have like a colored pen or like a highlighter, you could add this. This part is your angle bisector because it's splitting ABC into 2 parts. And that's also why there's 2 little arc marks here. These arc marks are kind of similar to when we did constructions. So your arc marks tell you that they are congruent. If that's ever in your picture, then let's just say I knew this was 30 degrees. Then I could say that this one is also 30 degrees. They are congruent. It's splitting it right down, meaning the whole angle was originally 60 and I'm cutting it in half. So a ray technically makes a ray divides an angle into 2 congruent pieces or 2 congruent angles. Because the ray is going straight through the middle. So in the diagram to the right, technically BD is the ray or is an angle bisector, creating 2 smaller angles that are also congruent to each other. So if I said angle, I don't know, CBD is congruent. So if I say CBD, what would CBD be congruent to? What's the other angle? You could say ABD or you could say DBA. Either way, this angle is congruent to this. You have to use 3 letters. So angle ABD. So those are both congruent. I said they were both 30 degrees. Okay, perpendicular lines. We talked about this a little bit. What's perpendicular mean? Boop. Not the same. What kind of angle does it make? Somebody said it, I think. A right angle, which is technically 90 degrees. So perpendicular lines make a right angle. So remember this square is 90 degrees. Okay. So 2 lines, any 2 lines that intersect, specifically intersect. Sorry, I can't like talk and write at the same time sometimes. At a right angle, because lines will not always intersect at a right angle. Sometimes they're going to be a right angle, like big plus sign. Sometimes they're not going to be a plus sign. So this specifically is not a right angle. This would be a right angle, so 90 degrees. So if they intersect, creating a right angle, the symbol for perpendicular, because we are math people and we don't like words, so perpendicular is a long word and we suck at spelling. So there's a symbol for it. So it's an upside down capital T. So when we do math tomorrow, we're going to have that symbol in the problem. Anytime you see this, that means you could add 90 degrees to your picture to help you solve whatever you're doing. So the upside down capital T means 90. So in the diagram to the right, I could say that line M is perpendicular to line L. They are intersecting at 90 degrees. So M is perpendicular to L. The last one we're going to talk about is perpendicular bisector. So perpendicular, once again, is 90 degrees. Bisector, we already know, cuts something in half or splits it in half. Okay, so if we're looking at our picture, this time it looks very similar to this. The only thing that's new is these little tick marks. These tick marks tell you that these 2 pieces are congruent to each other. Okay, so it's splitting it in half into 2 equal pieces. So if I knew, for example, that this was a length of 5 feet, this would also be 5 feet over there. Okay, so a line, segment, or ray, perpendicular, to a segment creates technically its midpoint. So it's in the middle. So if I take PQ and I split it in half, that is my midpoint. So it's perpendicular and it's going through the midpoint. In the diagram to the right, technically LM, which is a line, is the perpendicular bisector to what segment? What is LM cutting in half? PQ, which is not technically a line, it's a line segment. So if you want to put a little line with little dots, or you could just put a little line with no arrows, because PQ stops, it's got endpoints, whereas LM has arrows, so it would continue forever. Okay, so you have 2 problems on this piece of paper. If you are done with your test and you're done with your IXLs, you can work on these 2 problems. They won't take very long, okay? If you need to finish your test, I'm going to pass that out. So you're working on your test and you're putting it on Performance Matters. I do need to unlock it. It's not unlocked. And then if you need to do your test, then your IXLs work needs to be turned in. So it's kind of like whatever you need to do today, you're doing. You got test, IXLs, and then this piece of paper. What's that? Wait, what? Oh, the little line. This is a angle bisector. Oh, okay. So this little thing right here, it's called an arc mark. Boop, 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 boop. It's kind of like when we made constructions and we drew the arc. That is congruent that. Yes. So that's why I put 30. If it was 30, then the other one would also be 30. Okay. Stop recording so people don't have to listen to me.